You and your team, Adam, at Toustone, have been producing solutions that leverage artificial intelligence and machine learning for several years now. In fact, I hear Amazon approached your business to write a case study about the work in this area. Congratulations. Can I get it first then and ask what the difference is between artificial intelligence and machine learning, and what have you worked on in rail that leverages this? What have been some of the benefits?
Well, thanks for raising that nomination from AWS or Amazon. Yeah, look, we're pretty proud of the recognition that Amazon has shown, and frankly, it's a great acknowledgement for the team generally. It's not often that the might of an organisation like Amazon comes to focus on you, so we're very, very proud of that indeed. But look, your question is fantastic. What's the difference between AI and ML, or artificial intelligence and machine learning? It's actually often used interchangeably, actually incorrectly, frankly. But look, simply put, machine learning is a subset of the overall artificial intelligence concept. So AI is, if you like, the broader, I guess, concept where technology mimics the way that humans think, artificial intelligence. Yeah. In things like performing complex tasks such as, analysis or performing reasoning and learning and so on. ChatGPT, which I'm sure we're all familiar with now, is a great example of that, where, for all intents and purposes, it feels like you are talking to a person. It's this artificially intelligent type of concept. So in that broader artificial intelligence space, machine learning really is then a subset of that. Machine learning is about, using high performance computational resources and the power of, some of the technology that we've got now over enormous data sets, very, very large data sets, the classic big data concept, and applying learning techniques and algorithms to train and understand and learn from that data, hence the term machine learning, and producing models that do things like, understand why things happened, what are the relationships, explaining why things have occurred, to understand cause and effect analysis and so on. The classic example that most people use ML for is forecasting. So generating forecasts of an outcome based on historical patterns and relationships, correlations and so on, to provide highly accurate predictions of what's going to occur in the future. And as I said, what correlations between what you would expect to be unrelated events, but you actually, to understand that they are in fact related, becomes a significant insight. And that's the classic basket analysis. So what products sell with what? That leads to things like co-location of products in a shop. You don't realise it, but if you buy a jar of the peanut butter, if you put a loaf of bread next to it, the probability of the two selling together is very high. So they're good examples of machine learning. But in terms of examples of where we've used it in the rail industry, well, I've already touched on the energy consumption space. That is a classic case for forecasting and prediction. We have done other work around asset wear and so on. So, for example, things like track wear and overhead wire wear and so on, and understanding and correlating or relating influences on that wear of the asset. So, levels of acceleration or weather or speed or weight and all sorts of other influences that potentially could describe or at least explain the asset wear. And that gives the organisation information on which they can make decisions on how to minimise asset wear if they adjust their operations accordingly.